What I want to talk about today is joint work with Michaela Page, who you also see later today present another of her papers. And this is our joint project where we look at sticking to your plan, the role of present bias for credit card paydown. So what I'm going to do is I'm going to talk about the paper, and at a few points in the paper, I will stop and elaborate on some of the methods that we use and kind of tell you about them, so you don't just learn the content of the paper, but also hopefully a little bit about the process of how we got there and the methods you might want to use in your own work. Okay, so what is this paper about? This paper is about credit card debt and credit card debt pay down, and was motivated by the fact that a lot of US households, and as you've just heard from Johannes, hold a substantial amount of credit card debt. What we want to do in this paper is we want to understand the role of present bias in debt pay down. So there's two things that we're focusing on. The first one is present bias. This is an idea that has been brought up previously a lot for credit card payments, where people argued that the amount of credit card debt we see in the data is hard to explain with fully rational preferences and expectations, and one prime candidate for why people might want to borrow is present bias. The second part is debt pay down. So what we're focusing on in this paper is people paying down their debt. So we're going to speak about how do people reduce their debt once they've accumulated it. We're going to not so much focus on the accumulation. We're going to do this mostly empirically. We're going to use data on a sample of users of a financial management website. And the first thing we'll do is we're going to show you that many of these users actually fail to stick to their self-set paydown plans. We then want to understand whether that might have something to do with present bias. But to do this, we need to find a way of measuring present bias in the data. And so what we'll do is we're going to use a parsimonious model to show that we can infer present bias from high frequency consumption data. Once we've done that, we're going to estimate these measures of present bias, and we're going to relate them to debt pay down. We will show that sophisticated users pay down more the less impatient they are, and that planned paydown is more predictive of actual paydown for sophisticated users than it is for naive users. Before I move on, I want to briefly talk about present bias. What is present bias and how do we think about it? Present bias means that people are more impatient in the short run than in the long run. So you can see that in this utility function, we are actually going to model present bias this way. These are also the quasi-hyperbolic discounting preferences popularized by David Leibson. And so what you can see in these preferences is that they basically look the same as standard preferences, except this beta factor. But this beta factor means that people discount between the current and next period by beta delta, but between any future periods only by delta. And that makes these preferences time inconsistent, because from today's perspective, the discount factor between tomorrow and the day after tomorrow is delta. But come tomorrow, the discount factor between these two periods will be beta delta. And so because these preferences are time inconsistent, we can think about two extreme types of agents that distinguish themselves by what they expect their future preferences to be. The first one is individuals who are fully aware of these changing nature of their preferences, so who understand that while they currently discount between tomorrow and the day after tomorrow by delta, that tomorrow they will be discounting by beta delta. On the other hand, we can think about users or individuals that are fully unaware of this changing nature of their preferences, and we're going to call them naive. So this classification, or calling them sophisticated and naive, just follows the literature. That was a term coined by Matt Rabin for these quasi-hyperbolic discounters. And so that means that when we want to describe present bias and how different individuals might differ in the extent of their present bias, we have two features that determine a person's present bias. The first one is the extent of her short-run impatience, beta. How big is beta? In the extreme, beta could be 1, in which case this would be a perfectly rational exponential discounting agent. The lower beta, the more impatient in the short run this individual will be. But second, we need to know whether this individual is sophisticated or naive. In other words, whether this individual understands that the inconsistent nature of her preferences and that her discount factor between 2 future periods will change over time. Okay, let me preview what we'll do before I jump in. So what we'll do is we will relate these 2 features of present bias to spending patterns. We will do this in a parsimonious model, and we will show first that the level of short-run impatience, or beta in that sense, is captured by the sensitivity of consumption spending to paycheck receipt for biweekly paid individuals. Second, we will then argue that whether individuals are sophisticated or naive, that we can get at that by looking at how spending patterns change as people have varying degrees of resources over time. And I will explain this in much more detail when we get to it. Once we have that, once we have these measures, we can implement them in the data, and we can see how these measures relate to how well people stick to their debt reduction plans. What we're going to argue is that it is likely that people who are naive or unaware of their future present bias are repeatedly going to delay to pay back their debt as planned. In some sense, that's a key feature of models of unaware or naive present bias individuals, that they repeatedly delay executing their plans. On the other hand, we will argue that sophisticated users are much better in following through with their plans, and therefore they will be better in sticking with their plans. But we will also argue that people are more impatient, who just have a higher beta, who have a harder time being patient in the short run, that they will pay down less. So we're going to look that up in the data, and what we find is that we indeed find that the data is consistent with an important role of present bias, and then it's also inconsistent with many alternative explanations, such as credit constraints or unrealistic expectations, to just name a few, but we basically rule out everything we can. Okay, brief overview of where we're headed. I first want to briefly talk about the data. Then I'm going to show you present bias and high frequency consumption patterns in the model. Then I'm going to show you how we estimate them in the data. And then I'm going to talk about how they relate to debt paydown. The data we use comes from a website that was set up to help manage and pay down credit card debt. The website is called readyforzero.com. So what we have for these users is we have their balance, their credit limit, and the available credit on all accounts. We have transaction level data for the checking and the credit card. So basically, if you go to your bank statement, you see a line for each transaction. That's the type of data we have for all our users. We also have incoming payments. Most importantly, we have the incoming payment for paychecks, and so we know when they get paid. This data is actually the same information as in many transaction level data sets, and you see a lot of other papers have this type of data. What makes our data unique is that we also have how much people plan to pay down each month, which they enter into this website when they sign up. And this is really, that's something that's only in our data, and so that makes our data unique. So you'll see that our analysis heavily relies on having this extra piece of information, because that allows us to do what we're doing, kind of understanding how people deviate from their self-set payment plans when they decide how much to pay down. We include users in our sample. This is also relatively standard. If they have linked their checking accounts, that's to ensure that we observe the paychecks. If they have regular bi-weekly paychecks, so actually most people paid regularly are paid bi-weekly, so that's not a strict assumption, but of course not everyone has a regular paycheck. And for those individuals, we can't use our method. We then include people where we have data on all linked accounts available from sign up till after 180 days. So these restricts in two ways. First, that we need to have all linked accounts. So if we see that an account is unlinked, we don't see the full picture for this user and drop him or her. And the 180 days are just necessary. So we observe an outcome for them. Okay, the first thing we do in this data is look at this planned monthly paydown. Okay, and so what you see here, the first 5 columns, is what type of variables affect how much they plan to pay down. And you can see that a lot of the things that come out significant are basically the original debt levels and their monthly income. If they have higher debt or higher income, they plan to pay down more. In the second part, in the last 5 columns, we regress how much they actually pay down over 90 days on what they had planned to pay down. And so this is, the first column is per dollar. And so you see that basically for each dollar of planned pay down, the users in our sample pay down about 28 cents. So that's not very much clicking closely to their plan. They're falling short substantially. But what you also see is that actually, once we include plan paydown, none of the other variables is significant anymore. So despite the fact that people fall short in how much they plan to pay down, it is the single most predictive variable of actual paydown. Okay, so 2 things. Plans seem to be highly predictive of actual paydown, much more than anything else we can observe, but the users fall substantially short. They only pay down about 28 cents on average for each dollar of planned paydown. Okay, so now we want to think through to what extent present bias might help us understand these patterns. Okay. We're going to first look at this in our model because we need to argue and we need to make an argument that we can measure present bias in these consumption patterns. Okay. As mentioned, we have 2 features of present bias: the extent of the short-run impatient, or beta, and the awareness or the sophistication, in other words, the beliefs about their future beta. We're going to have a model where in our model we have a life cycle model. So our consumer lives his life, and importantly, the consumer has stochastic income every other period. That's important because what we will want to do later in the empirics, we want to exploit how sensitive people are to pay week versus non-pay weeks. And so we need to model this idea that we have a pay week versus a non-pay week in in regular intervals. The steps we're going to take is we're going to simulate the model. Then we're going to run the equivalent of our empirical regressions on the simulated data. And we're going to show how present bias manifests in these high frequency consumption data. But what I want to do now is I want to focus on the intuition of why did we come up with these regressions and why did we even start thinking about that they might reflect present bias in the data. Okay. So assume we have a consumer who receives a regular paycheck every 2 weeks. If we have a consumer with high short-run impatient, this individual highly values current consumption. So when she receives her paycheck, she immediately consumes a relatively big fraction of that paycheck. And then in the second week, when she's run short of money, she has to consume less because there's not that much left out of her paycheck. And what we're going to argue is that consumers who are more highly impatient in the short run will exhibit this behavior more strongly, that they're going to consume more immediately following paycheck receipt and then less in non-pay weeks. On the other hand, consumers with lower in the extreme no short-run impatience, these should smooth consumption over their pay cycle, and consumption spending should not depend on when their paycheck arrives. On average, they shouldn't be spending more or less in pay weeks rather than non-pay weeks. And so therefore, we're going to argue that higher short-run impatience is reflected in a higher sensitivity of consumption to paycheck receipts, and that we can use that as a measure. Okay, so that's the intuition. Let's see how that works in the model. So we simulate consumption and consumption spending over those pay weeks versus non-pay week versus pay week for our simulated users. And then we regress the log consumption on an indicator of whether it is a pay week or not. Okay? We do this for individuals with different levels of short-run impatience, and this is what we find. You can see here on the left for sophisticated and on the right for naive consumers that how much more they spend in a pay week increases the more impatient they are. So you can see here these are perfectly rational and standard hyperbolic discounting agents. The lower beta gets, the higher is the short-run impatience for these individuals, but also the lower beta gets, the more important is a pay week, the more they spend on average in pay weeks rather than non-pay weeks. Okay? So for both type of agents, we see that higher short-run impatience is reflected in a higher sensitivity of consumption to paycheck receipt. And we're going to use exactly that observation later on as our measure for short-run impatience. Second, we want to measure sophistication. So here the intuition is a little bit more subtle. I'm going to show you this in the Euler equation, and then I'm going to explain the intuition in words. So bear with me. We can solve the Euler equation for both the naive and the sophisticated agent. The Euler equation for the naive agent looks very much like a standard Euler equation, but in addition, it has this beta in here. Okay, and so the naive agent believes that she's going to be time consistent. She doesn't realize that her discounting factor will change in the next period. For the sophisticated, the Euler equation looks more complicated. And so the Euler equation is a weighted average between delta beta, just as for the naive, and simply the standard Euler equation. Okay? The weights are these terms here, and this is the future propensity to consume out of cash on hand or available resources. So what we see here is that the effective discount factor depends on this future propensity to consume out of cash on hand only for sophisticated individuals. The problem is that we don't observe this marginal propensity to consume. So we need to find a way to estimate this changing level of impatience for our sophisticated individuals. So our idea is the following. Well, we know what affects the marginal propensity to consume in the future. One thing is the level of resources. We know that because of diminishing marginal utility, individuals will consume less of any marginal unit of resources when they have higher levels of resources to begin with. Okay. And so we're going to exploit the variation in resources as a proxy for the variation in the future propensity to consume out of resources to see whether we find changing discounting for sophisticates in these cases. Okay, let me get at that intuition. So let's assume that sometimes the consumer receives a bonus payment or he receives a higher paycheck. So that would be a high resource pay cycle. A sophisticated consumer is aware of two things. The first one is her future propensity to overconsume relative to her long-run preferences. The second is that if she passes on resources, they are partially going to be consumed by her future self rather than being further passed on as her current self would prefer. This is the time inconsistency, the conflict of interest between the current and the next period self, where the current period self would prefer the next period self to save more, whereas the next period self is overly impatient relative to these long-run preferences, and she would prefer consuming more. So when there is a higher paycheck, then both the current as well as the next period self have higher levels of cash on hand or resources available to them. So they will have higher consumption and they will have a lower marginal propensity to consume because of this higher consumption and a lower marginal propensity to consume to begin with. But it also means that the future self has a lower propensity to overconsume. And so the current self knows that if she passes on a marginal unit of resources, that is more likely to be farther passed on and saved if resources overall are high rather than if resources are lower. And so for her, it is more worthwhile to act patiently and pass on these resources, knowing that the conflict of interest with her future self is a little bit diminished when resources are high, because the future self will act a little bit more patiently due to this lower marginal propensity to consume. And so passing on resources being more worthwhile makes the current self more worthwhile to pass on resources and consume a higher fraction out of that paycheck if overall resources are high. And we would therefore expect the same individual to have a little bit a smoother consumption profile when she has higher resources compared to when she has lower resources. This is the case for sophisticates. So we think they're going to be less sensitive to paycheck receipts when resources are higher. Let's now look at naives. Well, naives are completely unaware of their future propensity to overconsume relative to their long-run preferences. And so for them, the intra-temporal trade-off is completely unaffected, which means that the level of resources affects only sophisticates, and sophistication is therefore reflected in how the level of resources affects how sensitive they are to paycheck receipt. For naive consumers, we shouldn't expect a reduction. Okay, let's see how that pans out in the data. So we estimate this regression equation where we have our pay week as before. Now we have the level of resources and then the interaction, and this is the term we're interested in. How does the level of resources affect the pay week indicator? Do people become more or less sensitive? When we do this, we find, and we can see this here on the left, that for sophisticated users, we see a reduction in the level of sensitivity to paycheck receipt. So higher resources make them less sensitive. For naive consumers, on the other hand, we actually see an increase in our model and definitely no reduction. And so this will allow us to split people along whether we find an increase or a reduction and use that to classify them as sophisticated versus naive. Okay, now we know how to do this in the model. We're going to implement this in the data now. So first of all, we're going to separately estimate for each user how sensitive this specific user is to receiving a paycheck. So how much more on average does she spend in a given pay week? We include month fixed effects and day of the week fixed effects. If you work with this data, you'll very quickly see that they are very, very strong day of week fixed effects. People just spend much more on weekends. And then month fixed effects are important because we want to distinguish times of high spending, like the pre-Christmas season from other times. When we do this, and we do this both pooled as well as for each individual, we find that on average, people spend about 6% more in pay weeks, and this is for our category of what we call short-run consumables. If we look just as restaurant and entertainment spending, where we can be even more sure that this is really consumption spending, it's about 4.7, 4.6% more in pay weeks rather than non-pay weeks. Okay. And so we're going to use the sensitivity that we estimated here as a proxy for the level of short-run impatience. So next, we want to estimate the effect of resources. Okay? And we want to argue that if it's negative, then we can call people sophisticated. If it is non-negative or positive, we're going to call them naive. So we have a problem here because the level of resources is endogenous. First of all, spending directly affects concurrent resources, but spending might also affect the taste of consumption. So think about it. If I had a week of very high spending, maybe I went shopping and I went out for dinner and I went to the movies, then the next week I have both lower resources, but also I might just be less inclined to go out again because I just went out. So maybe I have less taste for consumption. And so that would mean that past resources are affecting my error term in the next period. So what we're going to do, well, first of all, we're going to measure resources at the beginning of the period. That solves the first problem. But second, we're going to instrument for the level of resources, and we're going to do this with the simulated balances as a simulated instrument. What is a simulated instrument? The idea of a simulated instrument, and this is something that comes out of public finance, is to isolate the exogenous part of the variation and filter out the endogenous part. So we need a source of exogenous variation. Usually you can use a policy change or discontinuity. What we're going to use is fixed timing of payments. And so what we do is we ask what would happen if there only was exogenous variation and we take out any endogenous response, what would happen to our resources? And we're going to use these simulated or hypothetical resources as our instrumental variable for the actual resources. Okay. So what we're going to argue is that people have regular payments, and so we can use the variation that comes from regular payments to estimate our effect. And so these regularly scheduled payments are exogenous to the short-run variations in taste for spending. Imagine this is a user who gets paid every 2 weeks, but they have to pay rent only once a month, so every 4 weeks. So now what we're going to assume is that this means the user, based on her actual spending, has some actual level of resources. They go up when she gets her paycheck, they go down when she pays rent and when she spends something. Instead of using these actual resources, we are going to simulate what her resources would have been if she would have spent an average over the whole sample horizon every day. In other words, instead of looking at actual spending, we calculate simulated spending, assuming that there's no endogenous response. And we're going to use that as our instrument. Yeah. So we use that as our instrument to estimate this regression. And then we're interested in this interaction term because that will tell us whether we are seeing a sophisticated or a naive person. These are the estimates down here. And here we can see how we classify users depending on whether we use short-run consumables or restaurant and entertainment spending only to classify people here. You can see that most people are actually consistently classified, but there are some people where this is not, where this is a little bit noisy. This is to be expected because that's a noisy estimate, but we're going to have to deal with it. Okay, let's now turn to debt paydown. So we have argued that we can show how present bias can be gauged from high frequency consumption patterns. We've estimated these high frequency consumption patterns, both the baseline sensitivity to paycheck receipt, and second, whether it goes up or down with the level of resources. Now we want to relate that to debt paydown. Okay? So we're going to regress debt paydown on the sensitivity on planned paydown, as well as both of these variables interacted with sophistication, so to get the differential effect for naive versus sophisticates, and a bunch of controls. Before I can do this, I need to talk about methods a little bit more. Usually when we estimate a regression, our regressors are observables. But in this case, they are not, because both sensitivity and sophistication are estimated. They are estimated with noise, and the noise, my estimation error in the first stage regression, is informative. So I can't just treat them the same as I would a randomly measured variable where I could think that the noise is maybe more random. So what do? I need to correct my standard errors for the fact that I've estimated regressors, and I'm going to have to use the first stage estimation noise as informing my second stage. The easiest way to do this is by just bootstrapping standard errors. What is the idea? The idea of bootstrapping standard errors is that you draw a sample from your data with replacement, and then you estimate the regression specification for each sample draw. And then you compute the standard errors based on these many repeated sample draws. The good news is that you can do this fairly easily in Stata, which many of us still use. The bad news is that the exact specification actually does depend on the specifics of your estimation at hand. So rather than being able to just completely automate that, you're going to have to think a little bit more deeply where you want to sample and then tell the Bootstrap command that. But it is actually relatively straightforward to do. And so if you have any of these issues at hand with estimated regressors or other non-standard errors, that's a very good thing to do to just be sure you get the standard errors correct. Okay, having spoken of standard errors, let's look at the results. So here we have Paydown over 90 and 180 days. We're going to have our regressors here, most importantly sensitivity and planned paydown, both of them interacted. Now we're going to look at 90 and 180 days when we use two measures of consumption. The first one is just short-run consumables. The second one is restaurant and entertainment. What you see here is that for naive consumers, their planned paydown is mostly predictive, but they fall substantially short. For instance, if you look at the short-run consumables estimate, they actually only pay down between 18 and 19 cents per dollar planned. If you look at restaurant and entertainment, it's a little bit more, but it's still a substantial shortfall. Now let's look how that differs for sophisticated consumers. We see two things. First of all, planned paydown is significantly more predictive of actual paydown for sophisticated than it is for naive consumers. So they pay down between 55 and 52 cents per dollar of planned paydown. This is much more than the less than 20 cents for the naive consumers. And you can see here how that difference of about 30 to 40 cents is highly significant. Second, we see that our sophisticated consumers, their paydown depends substantially on their sensitivity. Okay, so we see here sensitivity estimates are significantly different for sophisticated than for naive consumers. And to just give you a sense of the magnitude, because those numbers in and of itself are hard to interpret, is if we move a sophisticated person from the 75th to the 25th percentile in measured sensitivity, that increases that pay down up to by $623 over the first 90 days. That's substantial. That's about that's almost the average pay down over this period that we get from having someone who is relatively impatient in the short run relative to someone who's relatively patient. Okay, so what we saw is that these patterns are consistent with present bias or hyperbolic discounting or quasi-hyperbolic discount, however you want to call it. And we need to show that they're also inconsistent with alternative explanations. I have about 5 minutes left, so I'm going to talk you briefly through these alternative explanations and robustness checks that we do in the paper, knowing that I won't have time to get into each of them in detail. First, we show robustness for our specification. Basically, we want to show that our results don't hinge on the specific specification that we picked. So what we do is first we include sensitivity and planned paydown separately as separate regressors, because you might be concerned that if the short-run impatience also affects planned paydown, then that could somehow weirdly influence the results, and we find essentially the same thing. Next, you might be worried that there is a direct relationship between the reduction sensitivity, which we use to classify people as sophisticated versus not, and Paydown. And so then we would somehow be misspecifying the model. We can estimate that, so we can estimate whether the extent of the reduction in sensitivity affects Paydown. Recall that we just use whether there is a reduction or whether there's not a reduction, so we turn this into a binary variable, sophistication. If we use the extent of the reduction in sensitivity, we find literally no relationship. It is just the magnitude varies, the coefficient varies, and everything is highly insignificant. So that doesn't seem to be the case. Next, we look at robustness for estimating sensitivity. And so first we vary the days required for sample inclusion. We vary how we measure spending. So we use log spending in our baseline, but we can also look at absolute spending or at weekly spending instead of daily spending. We can also do this with just debit card spending rather than both debit and credit card spending. And no matter what we do, we find the similar consistent results. Third, we're going to look at the robustness of estimating sophistication. Okay? And so we do two things here. The first one is that we exclude low levels of sensitivity. The second one is that we focus on only the consistently classified users, so users who are classified the same, irrespective of which type of consumption category we use. I want to show you briefly excluding the low levels of sensitivity because I do think that's the one that's actually most theory-driven. So if you think about it, if we have people with a low level of sensitivity, so these people are barely present bias, they're being close to standard rational exponential discounters. For these people, the distinction between sophistication and naivete is first not meaningful, and second, they are most likely to be mismeasured because you're trying to pick up a change in something that's very small to begin with. And so we should expect that any differences we pick up in the estimation, if our story is correct, is really driven by those users that have a substantial extent of short-run impatience, who have a substantial high level of sensitivity. And so to see that, we exclude from our baseline the 10, 15, 20% of users with the lowest estimated sensitivity. What you see here, despite the fact that we're really losing a lot in our sample, our estimates don't budge. Neither the point estimates, not actually the significance. And this indicates that it is really these high sensitivity users who are driving our results, exactly as theory would predict. Okay. So the last part where we want to show robustness are alternative explanations. The first one, the most important one that people always bring up, what about credit constraints? Could credit constraints explain our level of sensitivity? And so we do filter out people that are likely to be credit constraints. Others are habits and non-separabilities or unrealistic expectations, where we explain in detail in the paper how these are not consistent with our results, but I want to briefly show you the credit constraints. So what we do in our baseline is we already try to rule out, to kind of filter out times where users would be likely constrained. That is, we check, could they have afforded the spending of the pay week in the week prior? And we only include those weeks where they don't look constrained. We do two stricter things here. We include a buffer stock model, or whether all type of spending would have been affordable. And we find essentially the same results for our regression, indicating that this just doesn't seem to be the cause of what's driving our results here. So credit constraints might be going on, and we do filter them out indeed, but they don't drive our results. Okay, So I'm 1 minute short of my end, so let me conclude. We hopefully showed that present bias can explain the patterns of consumption and success in debt paydown. The distinction between sophisticated and naive individuals turns out to be very important. We do find that sophisticates are much better in sticking with their debt paydown plans, and for them, those that are less impatient in the short run pay down substantially more. Naive individuals, on the other hand, have very big problems sticking with their debt paydown plans and really just pay down a fraction of what they had planned to. We also introduce on the methodological side the idea that we can measure short level impatience and sophistication that we can infer it from observed consumption choices. And we think this is a measure that could also be used in other settings as this type of data becomes more and more available. And so finally, our findings have some implications for the regulation of consumer products, for financial service providers who want to understand customer behavior, and of course for policies to help consumers get out of debt. If we know that many struggle to follow through with their debt paydown plans, despite their best intentions, we can actually help them better stick with these pay down plans and maybe be more successful by offering them help with those things rather than just approaching it in different ways that doesn't take into account their potential biases. Okay, I'm out of time and I already see Scott here who's next in line. So I'm going to hand over to Scott.
No, so let me, thanks, Theresa. So I think we're going to take a 15-minute break now before we go to Scott. I just want to say two things about the paper you present and sort of why I think what's kind of cool about it. So I think the first one is that one of the things you see in this paper is that once you start going down the behavioral economics route, the theories start getting quite tricky quite quickly.
Yeah.
And the predictions from the theory, the ability to differentiate things like naive present bias versus sophisticated present bias, that's not straightforward. And so one of the things I really like about the paper is this tight link between sort of what these theories say, and actually a lot of the literature on naive versus sophisticated present biases being driven by the theory side, in part because they're so hard to distinguish in the data. And so I think that's sort of one thing I want to highlight. The other thing I want to highlight, and we'll come back to that when we have sort of our panel discussion, but one of the things you'll see for all the presentations today is that they use sort of micro data sets, and here it's sort of a it's a micro data set that comes from a fintech platform, and Michaela will also present a paper with a micro data set from a different fintech platform. And one of the things we'll talk about, and I just want you all to think about already, is this idea, when you work with these, you're always going to get questions about how representative is the population and so on. And one of the problems you're going to run into inevitably with these data sets is people are going to say, well, who signs up for these platforms? Well, it's a very selected sample of individuals. And I think that is true. And I think one of the things I really think is cool about this paper you just presented is that the selection in many ways is exactly the selection you would want, right? So you say, well, yes, people sign up to this platform because they want to pay down their debt. And so then you can think about, well, what types of questions can I answer better by focusing on a sample of people that want to pay down their debt, right? And it's exactly this, well, why don't they if they want to? Right, that's kind of a natural question. And so I think how you kind of, how this paper allows you to turn what upfront might look like a liability in terms of, a very selected sample, a very special sample, into sort of a strength that allows you to answer a specific question. I think that's cool, and something that, we want to come back to in the panel discussion at the end about sort of these different data sets. They all have selection issues, of various dimensions, but how do you deal with those selection issues, and how do you try and turn them into an advantage where there could be a disadvantage? So we'll come back to that at the panel, but I just wanted to add that at the end as kind of two things that I think you can take away from this paper beyond obviously the sort of specific content that I think have sort of broader applicability. So we'll take...
Yeah, can I take a minute to adjust to this?
Yeah.
Because I think we have a lot of PhD students in the audience. And so I think for those of you who are not aware, this was my job market paper. And so I think this actually shows what some of what Johannes pinpointed, that we have challenges, especially if you're a job market candidate trying to write your job market paper, and where you can turn that into an advantage. You saw our data. I mean, it's not huge. We don't have a lot of observations, and it is very selected in the sense that everyone who signed up for this platform wanted to reduce their debt. And so the big challenge we faced really was finding the question that our data set would be well suited to answer. And so part of it is the selection. I think the other part is this little nice extra feature that this specific data has that no one else has, is like this plan pay down, which allowed us to do this whole machinery about saying, look, people want to pay down, but they're falling short. And we want to understand why it is that they are so having such a hard time following through with their debt pay down plans. And so observing those plans was absolutely crucial for that. So I do think this, if you see the finished paper, you don't see the struggle that preceded it in finding exactly this question. I want to also highlight one other thing that I think worked really well in this paper that helped us in the publication process is how we, in the end, were able to really match the model in the theory to the empirics and to tightly tie them together so that we were able to show in the theory model, from the theory side, that this measure that we were going to use empirically worked in theory, okay? And I think that's something that is a chance for a lot of PhD students to use some more theory-informed empirics to just tighten that and to come up with new ways to use data where previously maybe you didn't have those options.